Howdy everybody, this is my presentation on DeepMind's AlphaGo Zero. DeepMind recently made great strides in AI with its AlphaGo program. It all began in October 2015 when the program beat the European Go champion Fan Hui in a game of Go. This was the very first time an AI defeated a professional Go player. Then the company made headlines again in 2016 after its AlphaGo program beat Lee Sedol, a professional Go player and a world champion. Furthermore, in late 2017, an improved version of the program called AlphaGo Zero defeated AlphaGo. The best part? AlphaGo Zero's strategies were self-taught. As a result, AlphaGo Zero defeated its predecessor in only 3 days, with less processing power than AlphaGo. However, the original AlphaGo, on the other hand, required months to learn how to play. All these facts beg questions. What makes AlphaGo Zero so exceptional? Why is it such a big deal? How does it even work? So without further ado, let's dive into what, why and how of DeepMind's AlphaGo Zero. Simply put, AlphaGo Zero is the strongest Go program in the world. As explained earlier, it monumentally outperforms all previous versions of AlphaGo. Now, all previous versions of AlphaGo were trained using human data. As a result, the previous versions learned and improved upon the moves played by professional Go players. But AlphaGo Zero did not use any human data. Instead, it had to learn completely from playing against itself. According to DeepMind's professor David Silver, playing against itself enables it to do much better than using strong human data. Because AlphaGo always has an opponent of just the right level. So it starts extremely naive with perfect random play. And yet, at every step of the learning process, it has an opponent that's exactly calibrated to its current level of performance. So to begin with, these players are terribly weak but become progressively stronger and stronger over time. Architecture. AlphaGo Zero is able to achieve all this by employing a novel form of reinforcement learning, in which AlphaGo Zero becomes its own teacher. As explained previously, the system starts off with a single neural network that knows absolutely nothing about the game of Go. By combining this neural network with a powerful search algorithm, it then plays games against itself. As it plays more and more games, the neural network is updated and tuned to predict moves and even the eventual winner of the games. Both AlphaGo and AlphaGo Zero took a general approach to playing Go. First, both evaluated the Go board and chose moves using a combination of two methods: look ahead and intuition. Look ahead. Before AlphaGo, all finest Go programs tackle this issue using Monte Carlo tree search. This process involves initially exploring numerous possible moves on the board and then focusing this search over time as certain moves are found to be more likely to result in wins than others. AlphaGo Zero apply a fairly elementary version of Monte Carlo tree search for their look ahead to correctly maintain the trade-off between exploring new sequences of moves or more deeply exploring already explored sequences. Although Monte Carlo tree search has been at the heart of all effective Go programs preceding AlphaGo, DeepMind's smart coalescence of this method with a neural network based intuition enabled it to attain superhuman performance. So what's intuition? DeepMind fused value networks and policy networks with Monte Carlo tree search, that is programmed intuition, with brute force, look ahead, search. AlphaGo Zero's neural network architecture can be referred to as a two-headed architecture, where one head takes the output of the first 20 layers and presents probabilities of the Go agent making certain moves. The other head takes the output of the first 20 layers and generates a probability of the current player winning. What's more, AlphaGo Zero used a more state-of-the-art neural network architecture as opposed to AlphaGo. Notably, it used residual neural network architecture rather than a plainly convolutional architecture. So, what are the marketing complications? In 2012, Marketing AI Institute founder Paul Reutzer theorized that AI would make it possible to create a true marketing intelligence engine. This engine could recommend a marketing strategy based on past marketing performance that is better, faster, and cheaper than humans. Reutzer started by releasing Marketing Score, a free online tool that accesses your marketing foundations, forecasts, and align expectations. Marketing Score is just the beginning. It relies on humans to rate its marketing programs across 130 different factors. It then uses human coded algorithms to weigh these responses and highlight marketing assets, gaps, and opportunities. Unfortunately, the system is currently limited by the amount of data available and the human device tools that pass it. Moreover, it does not learn on its own or iteratively teach itself to improve. On the other hand, AlphaGo Zero presents the possibility of self-learning AI systems becoming progressively better at highly complex goal-based tasks without human data or expertise. With further generalization, the AlphaGo Zero algorithm can become a strong AI that can act as an intelligence engine. However, this will make human intelligence suboptimal, and we must have proper strategies to ensure AI safety and avoid potential losses. That's the end of my presentation. Thank you.